Hi, the goal of this video is to show you how to program your microcontrollers using Toit. Toit is the framework we're using for our microcontrollers, mainly because it has this really nice feature of being able to update our programs over Wi-Fi. That'll be really nice when your robot is halfway across the room and you don't have a long enough USB cable to update the programs. On my MacBook, the way to install Toitlang is with Brew. I'm not going to run this command again because I've already run it recently to install and update the program used to update Toitlang itself, the program being JAG. And once you have Brew installed, the next step, which I'm also not going to run here, just because I just ran it right before the video to make sure everything worked correctly, is JAG setup. That will essentially install the current version of the Toit and JAG framework. We will probably stick with the same version that is available right now throughout the rest of the semester. That way, all of the code that we have currently is compatible. And I'll let everybody know over Slack if I make any changes and that we need to update our version of Toit. The next step is to plug in your microcontroller. And I could actually lift the microcontroller out of the expansion board here and plug it directly into the USB cable without all the other wiring. But then I'd have to plug it back in, and that's going to be a little bit obnoxious. So I'll just leave it seated inside the expansion board with everything else connected. One nice thing about the way that we have this wiring harness, the battery wiring harness, is that plugging into the USB cable will never be able to power your motors. So we don't have to worry about this thing taking off on us if we have some sort of bad programming setup. Now that our board is connected, we should be able to run the JAG flash command from the command line. And the default chip is not the chip we have, so you'll want to specify that we're using the ESP32S3. And as I mentioned, one really nice thing about using JAG and Toit is that it lets us update our programs over Wi-Fi. So our laptops or desktops, whatever you're using, need to be connected to the same network as the microcontroller. And this is where we specify the network that the microcontroller should connect to. The campuses have a special network specifically for small devices like this. And it's called the Claremont ATC network. And next I have to put the password in. And the password will show up on the Slack channel. I won't put that here just because I'm supposed to limit the number of people who have access to that network. What JAG is doing now is it's actually uploading a new program and loading it into the permanent storage on the microcontroller. So if I were to unplug the microcontroller and eliminate power from it and then plug it back in, this same program would be running on it. And one really nice thing about this program is it has a nice utility for connecting to what's called a serial monitor. So if I type JAG monitor, it'll actually output any messages from the programs you have running on your microcontroller and spit them out here into the terminal. My font size here is a little bit large, but there is some really useful information in this output. And I should actually scroll back up all the way to this JAG flash command, because there is one other additional output that I want you to take note of, which is the MAC address. I'll need a listing of all the MAC addresses for all microcontrollers in the class, so this is something that you'll have to put on Gradescope as part of your exercise. But out of the JAG monitor, down to the JAG monitor output, the thing we want to take close attention to is the IP address here. I'm going to copy the IP address because we're going to want to connect to the microcontroller in a separate window. So I'm just going to split my pane here, and I'm going to leave JAG monitor up, which means if I have any programs running and they spit something to the output, it'll show up in that window. And now I'm going to show you how to run your first programs on the microcontroller. If you look at the text next to this video, it'll show you the repository where you'll find some working examples. And the command should look something like this. And I already have this repository cloned on this computer, so I'm not going to clone it again. Instead, I'm going to jump into that directory. So this is the set of demo code and actually library code that we'll use throughout the semester, and I'll add to this throughout the semester. The first program we're going to start with is the Hello World program, and you'll find that inside the Hello directory. The only file in this directory is a Toit source file, and if we look at the output of it, it really is just print Hello World. So this program will start, it'll print Hello World, and then it'll end. And you should see that output here in the upper pane when I actually run this program. The Toit documentation says we should run the program with jag run the file, but this will not work on the Claremont ETC network. It says it didn't find any Jaguar devices, Jaguar being the tool that Toit uses to upload new programs. That has to do with a setting inside Claremont ETC. It's filtering out a lot of messages that are being broadcast across the entire network, which is how the firmware that's been uploaded on your microcontroller works. It broadcasts that it exists, and those just aren't getting through to the laptop I'm running on here. So instead, we'll have to run jag run the program, and then this is why I had you note the IP address, which in my case is 172.2.8.91.126. And I should warn you that if you get a hold of any of your neighbors' IP addresses and are uploading programs to those, you'll be overwriting whatever they have running on there at any given time. That would be really bad. You don't want to have your code have incompatible changes with their hardware, and so you could cause some pretty significant damage by not knowing your IP address. So always double and triple check that you're using the correct IP address before you run any programs. I'm not entirely sure what happened there. It looks like it was unable to connect to my device. Let me see what happens if I call jag monitor again. That'll reset the device. It could be that my device was kicked off of the Wi-Fi somehow. Alright, it says it's connected. 127 or 172. Let's try that again. Jag run hello device 172.28.91.126. Alright, no problems that time. And you can see in the output up top, it says my program has started. It ran my program, which just is the Hello World program, and then my program stopped. Let's run something a little bit more interesting. Inside the LED directory, you'll find two files. One called led.toit. You could think of this as a library file. You can't actually just run this file itself. And another called demo. And I'll actually start by just showing you what happens if you try to run the led.toit file itself. It says, couldn't find main inside that file. And that's correct. That file is just really defining a class that we can use in other files. So let's run the demo file. And now I need to remember my IP address again. 172.2.8.91.126. The program has been uploaded, and it should show up well enough that the LED is flashing on the microcontroller. This LED in the right next to the USB connector. That's the program that's currently running on our microcontroller. You can see the previous program stopped, this program started. There are no print messages, so nothing else has been on output, and we don't have any message about the program stopping. And we can see why if we dig into the code for the demo. Inside the demo, we create an LED object, and while true, we turn it on for 1 second, then we turn it off for 1/4 of a second. And that program just loops infinitely. So it'll never end and it'll never stop unless we purposefully stop it. One way to stop it is to end the jag monitor program and then call jag monitor again. And whenever you call Jag monitor, it restarts whatever program was, actually it eliminates any program that was running on there and just starts from a blank slate. In fact, if we were to unplug the microcontroller and plug it back in, it wouldn't run that LED sketch either. When you do Jag run, it uploads the program into RAM, so that's temporary memory. It's volatile, meaning on any sort of power reset, it's completely lost. Next week, we'll talk about how do you run a program and have it run and stay on the device even after a power reset. But that is all for this first video. And the next video, we'll talk about getting the motors to run.